You're welcome to Excellent Simplified Tutorials.
So today we'll be talking about permutation and combination. Permutation and combination. And when we talk about permutation and combination generally, we are looking at a way of arranging objects from a given set. A way of arranging objects from a given set. Let's take for example in this class. Let's assume you are 20 in this class and I want to select 3 persons. Okay, I want to form a group of 5 from 20 persons. That is, as you are 20 in this class, assuming, and I want to form 5 groups, group A, B, C, D, E. How do I pick you and arrange in those groups? So in permutation and combination, we are just looking at a way of arranging objects. Now, a permutation of n distinct objects taking arrow times at a time, is an arrangement of arrow out of the n objects with attention given to the order of arrangement. Now, this is grammar, but the basic thing here is, if you want to arrange, let's say I have something like this. I have 3 persons here, A, B, and C, and I want to take them 2 at a time. In what order can I arrange them? I can take AB, right? I can take AC. What other way? BC. What other way? BA. What other way? What other way? CA. What other way? CB. What other way? That's all right. Now, if you are looking at, you are arranging this from a given set. This is permutation or combination. The difference is they are very similar. They are like identical twins. But the difference is in permutation, you consider order. While in combination, the order is not necessary. Now, if the order of arrangement, the tools, if the order of arrangement is important, what do you use? Is it permutation or combination? Permutation, right? But if the order of arrangement is not important, you use what? Combination. Now, in permutation, David, D for David, David can come before Gloria, right? Gloria can come before David. They are 2 different things because the order is very important, is it not? Jane can come before Felix, right? Felix can come before Jane. Which other way can we combine? David to Felix, right? Felix to David. Which other way? Jane to who? Jane to David. David to Jane. Which other way? That's all right. Okay, now, so in how many ways can you pair them in twos? 4 ways, right? Good. If you are using this formula, n factorial all over n minus arrow factorial or factorial, the n is the total number of persons there. And the arrow is how many are you combining? How many are you taking at a time? So in this case, we are combining how many? The total number of persons there are how many? 4. So we have 4 factorial all over 4 minus arrow now is what? 2, right? Or factorial. So we'll be having 4 factorial. Factorial means, we said, if you are saying factorial, factorial is 4 times 3 times 2 times 1. They say find the factorial of 10. 10 times what? 9 times 8 times 7 times, like that until you get to 1. So 4 factorial is 4 times 3 times 2 times 1 all over 4 minus 2 is what? So we have 2 factorial. Now 4 times 3 times 2 times 1 will give us what? 4 times 3 is what? 12 times 2 is what? 24 times 1 is what? 24, right? Now 24 divided by 2 is what? Is what? 12, right? So if you arrange this, this is supposed to give you 12, not 8. There are 3 other ways you can combine them. Like what to what? Gloria to who? To Jane. Jane to Gloria. What else? Gloria to. So if you arrange all this, you should have 12, right? You should have 12. That is permutation. But in combination, the order is not important. So So this is what that means. If I have something like this, AB equal to BC, BA, is this combination or permutation? Combination, right? Because the order is not important here. But if AB is not equal to BA, this is what? Permutation, because the order is important. This is not equal to this. Do you understand that? In combination, we said combination is a way of selecting items from a collection such that the order of selection does not matter. The order of the collection does not matter. The way you are arranging it does not matter. Now we say a combination of n different objects taking arrow at a time is a selection of arrow out of n objects with no attention given to the order of arrangement. Now the first and the second definition are totally the same thing. This is in mathematical terms. So we can represent that as n factorial. Please pay attention here. There's something I want to point out. N factorial all over n minus arrow all factorial, arrow factorial. If you look at this, you discover that this part of the formula for combination is for what? This part is for what? Permutation, right? So you agree with me that this is the same thing as is it the same thing? Permutation all over arrow factorial. Is it the same thing? It's the same thing, right? Because permutation now, we have permutation as what? N factorial all over what? N minus arrow factorial all over arrow factorial. Is it not? I don't know if you are following. What times? Yes, we are coming there. Now this, if you look at this is the same thing as saying n factorial all over n minus arrow all factorial divided by arrow factorial, right? That is that stuff there, is it not? And we can, this is the same thing as saying n factorial all over n minus arrow all factorial times what? 1 all over arrow factorial. You remember, if you want to change division to times, you take the reciprocal. So we are back to n factorial all over n minus arrow factorial, arrow factorial. Do you get that? Let's look at this question. The value of this is the same as the value of dash. Now if you look at this, what's the answer? What's the answer here? Is this factorial? What's the answer from here? If you look at this, is this the same thing as combination? Permutation times arrow factorial, is it the same thing? No, right? Is this the same thing? Is this the same thing? If you look at this, what's the answer? B, right? B is the simple answer there, because this times 1 is just like writing it like this, which is what we got from the other side there, which is this. Example 1. Can we solve that together? Now the question says 4 candidates, Henry, David, Felix and Gift, applied for scholarship in Ajib and Share. Full stop. Each of the scholarship must go to a different candidate. List the possible ways it can be awarded. Now understand the question. How many scholarships did they apply for? 2, right? Good. How many persons were applying for the scholarship? 4 persons, right? But now each of the scholarship must go to a different candidate. Must go to a different candidate. Now to solve this, let's ask ourselves. Now look at this. The first thing you will need to know when answering questions like this is ask yourself, is this permutation or combination? Once you can answer that question, you've gotten the answer. So in a question like this, is the order of arrangement necessary? If the order of arrangement is necessary, is it combination or permutation? Permutation, right? If the order of arrangement is not necessary, it's what? So in this question, ask yourself, is David Felix equal to Felix David? So ask yourself, if David Felix equal to Felix is David Felix equal to Felix David? This is what I mean. Now the scholarships are Ajib and share, right? If you arrange David Felix this way, it means David is or Ajib got Ajib scholarship and Felix got what? Share. If you arrange it this way, it means Felix got what? Ajib and this one got what? Share. So is this equal to this? I don't know if you understand. Look at this. David Felix. Arranging it this one. David coming before Felix. And here Felix coming before David. From the order of the question, we are giving Ajib and share. Meaning if you put these two names together like this, it means the first person got Ajib scholarship and the second person got share. Is it not? So I'm asking, is David Felix, these two persons are these two persons also. Is it not? But the order is different. Is this equal to this? It's not equal, right? Because in this first case, David got Ajib scholarship. Is it not? In this second case, David got what? Share scholarship. In the first case, he got Ajib. In the second case, he got share. Meaning that this is not equal to this, right? So if this is not equal to this, is this permutation or combination? Permutation, right? Remember, I told you if AB is not equal to BA, then this is permutation. But if AB is equal to BA, then this combination, it means the order of arrangement is not important. But yeah, the order of arrangement is important. So this is a case of what? Permutation. So we can use permutation formula and solve, and we'll get our answer. So in this case, we'll go with permutation. And the formula for permutation is equal to what? N factorial all over what? N minus r all factorial. Is it not? Now let me ask. Our n here is what? Our n here is what? How many persons are here? 1, 2, 3, 4, right? 4. Good. N 4 factorial, right? How many scholarships are they contesting for? 2, right? So our n here is T4 minus what? 2. Or what? Factorial. Good. So we'll be having, please don't make the mistake of putting only this factorial with 2. This factorial applies to everything. So here you'll be having 4 factorial all over. 4 minus 2 is what? 2 factorial, right? Good. Now, 4 factorial is the same thing as what? 4 times 3 times 2 times what? 1, right? All over. 2 factorial is equal to what? 2 times 1. This 2 times 1 can cancel this 2 times 1, right? Or you do your normal multiplication out. Which will give us 4 times 3 is what? So it means the scholarship can be awarded in 12 ways. In 12 ways. What that means is Henry to David, David to Henry, David to Felix, Felix to David. Like you can arrange these things in 12 different ways. That is what it means. Do you understand that? So the answer to this question is 12 different ways. The scholarship can be awarded in 12 different ways. You are done. Any question on that? Okay, let's solve it together. Are we done with this? Good. Now, the second example here, out of the science club members of a school, A, B, C, D, and E. So these are the science club members. These 5 persons. just 3 are to be chosen to represent the school in an exhibition. In how many ways can this be done? First, you have 5 persons in the club, and you want to choose just 3 persons to represent the school in an exhibition. In how many ways can you choose 3 persons from 5 persons? Now look at this. The first question you ask yourself, is this a case of permutation or combination? So in this case, what do you think? Combination. Let's see if it's combination or permutation. Now if you look at this, if I choose, how many persons are we choosing? 3 persons, right? If I decide to choose A, B, and C, and on the other way, I decide to choose B, C, and A. Is ABC equal to BCA? Like if I choose, okay, 3 of them now. Your Favor, your Gift, and your Amaka. Now, there are 5 in a class. 5. Okay, let's use this 5. These are 5 persons, but these are the 3 I'm using now. Out of these 5 persons, I want to choose 3 persons to represent the school. Now, if I choose Favor, Gift, and Amaka, or I choose Gift, Amaka, and Favor, are they the same thing? They are the same set of persons, right? So in this case, the order is not necessary. Whether you choose this one before this one or this one before this one, the fact is that you are still choosing 3 of them. So the order of choosing them is not necessary. Do you understand that? So in this case, ABC is equal to BCA, because they are still the 3 persons representing the school. You not go there in the competition, they will not ask you who did they choose first. What they know is these are the 3 persons representing the school. So the order is not important. Do we get that? So since this is equal to this, then this is a case of what? Combination. And we know that in combination, the formula is equal to what? N factorial all over what? N minus arrow all factorial arrow factorial, right? Good. Now our N here is what? How many persons do we have in the club? 5, right? So we have 5 factorial all over 5 minus. How many persons are we choosing to represent the school? 3, right? So 3 all factorial, 3 factorial. Now you'll be having, you will know that 5 factorial is 5 times 4 times 3 times 2 times 1, right? So here you'll be having 5 times 4 times 3 times 2 times 1 all over 5 minus 3 is what? So we're having here 2 factorial, 3 factorial, right? Is which one will cancel what? 3 factorial can cancel this one, right? Because you know 3 factorial is 3 times 2 times, is it not? So this is the same thing as 3 factorial. This can cancel this out. So we'll be having 20 divided by what? 2 factorial is still 2 times 1, 2. Which is what? This guy is an excellent guesser. Alright, so the answer there is 10. A case of combination. So you can select them in 10 ways. Do you understand? Example 3. How many ways are there of arranging 3 different jobs between 5 men where any man can do only 1 job? Now let's look at it this way. How many jobs do we have in total? 3, right? How many men are there? 5, right? Now, the first question you ask yourself, if we have something like this, A, B, C, this is man A, man B, and man C. If you arrange it like this, it means man A did job A, right? The second man here did job B, and this job what? Is it not? If I arrange now, is ABC equal to BAC? No, right? Because this means that this one did job A, first job, second job, third job, right? First job, second job, third job. But here now, okay, first job, second job, third job. From this first one, A did the first job here, right? But A did the second job in this other one. Do you get? Do you understand? Let's say maybe the first job is typing, the second job is cleaning, and the third job is washing. Good. Here A is typing, but in this second arrangement A is what? Is cleaning. Do you get? So the order of arrangement here is important because ABC is not equal to BAC. So the order of arrangement is important, and since the order of arrangement is important, is it permutation or combination? Permutation. It's permutation. So now, since we've known that this is a case of permutation, we'll apply our formula. Permutation is equal to what? N factorial all over what? N minus what? Arrow, all factorial, right? Now, N is what? N is what? 5 factorial, right? All over what? 5 minus what? 3 all factorial. Is that what you did? Now, 5 factorial all over 5 minus 3 is what? 2 factorial, right? Is it not? Good. Now, in this case, 5 factorial is what? 5 times 4 times, is it not? And 2 factorial is the same thing now. So we have this 5 times 4 times 3 times 2 times 1 all over 2 times 1, right? Is it not? So this can cancel this, right? So we are left with 5 times 4 is what? 20 times 2 is what? 20 times 3 is what? 60. So 60 ways. 60 ways. That's the answer. So it all boils down to knowing whether it's combination or permutation. If you know, then you get the answer. In the equation, as you're seeing, they're not telling you use combination or permutation. Just understand the equation. Is the order of arrangement important? If the order of arrangement is important, if the order of arrangement is not important, combination. As we go on with different examples, you'll get used to it. You'll know on your own. Please try to solve. Don't wait for us to solve together. Example 4. In how many ways can 8 people be seated in a bench if only 3 seats are available? Only 3 seats are available. How many persons do we have? In how many ways can they be seated? Let's use these 3 persons sitting here. If this one is sitting here, if I bring her from here and I put her here, is the arrangement still the same? It's no longer the same. You've altered the arrangement. So here the order in which they are sitting matters. Because if anybody comes to the class now, they'll know she's sitting at the middle. If I remove her and I put her here, another person comes, oh, she's not at the middle, she's here. The order of arrangement matters. This is what I mean. We have 8 persons. And we have 3 seats. These are the 3 seats. It means only 3 persons can sit at a time, right? Only 3 persons can sit at a time. Now, if the 8 persons are A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 persons. Only 3 persons can sit at a time. Now, if we have something like this, A sits here, B sits here, C sits here, and we have another arrangement like this. B sits here, C sits here, A sits here. Is this arrangement the same with this? It's not the same, right? It's not the same because this one in this place, A was sitting on the first seat, but here A is sitting on the last seat, so it's not the same. So in this case, ABC is not equal to BCA. Now listen to the question again. In how many ways? If I arrange them like this, this is one way. If I bring and put here, this is another way. If I bring this one and put here, this is another way. Do you get? So in how many ways are they seated? So here the order of arrangement matters. So if the order of arrangement matters, are we talking about combination or permutation? Permutation, right? So what we are using here is permutation. So knowing that, we have this. What's the formula? N factorial all over what? N minus r all factorial. Our n here is what? I'll show you a little shortcut here. Our r is what? Our n is what? 8 factorial all over our 8 minus 3 all factorial, right? And this is equal to what? 8 factorial all over what? 5 factorial. Now this is the same thing as saying 8 times 3, 8 times what? 7 times 6 times what? 5 times 4, right? But we have 5 now, I can stop here, 5 factorial. Because 5 factorial is 5 times 4 times, is it not? All over what? 5 factorial. So 5 factorial can cancel 5 factorial out. And we're left with saying 5 times 7 times 6. Which is what? So you can arrange them in 336 ways, 336 ways. That's the simple answer. So it all boils down to knowing if it is permutation or it is combination. Once you know if it's permutation or combination, you are good to go. This is, your head is getting hot. They are selling water there.
They don't have water.
They don't have water. Buy soft drink. They want to say no, so I would think they are solving.
Yes, I've got my own.
What's your answer?
I go on to it, I go one.
I like the fact that you are not giving them options. Let's solve this together, please. Hello? Hello? Can we solve this together? Yes, we can. Example 5. If the mathematics department of a college has 5 members of staff and they are to pose for a photograph by standing in a row, how many different arrangements are possible? Solution. Now, how many persons do we have? 5, right? Now they're asking us, how many ways can you arrange them? There are 5 persons. So in this case here, will it be permutation or combination? Permutation or combination? That is the big question. Because, okay, now I have, these are the 5 members of staff. These are the 5 persons. This is one way I can arrange them. I can say, okay, you stand here, you stand here. I can say, is this arrangement the same thing with this arrangement? It's not the same, right? I can switch the other person like that. So in this case, do you say it's permutation or combination? Permutation or combination? Now the order of arrangement matters. So is what? Permutation. Because the order of arrangement matters. This arrangement is different from this. Okay, if you are standing like this and I snap you, I take a photograph. This first case, this is you. Say you are this person. And this other case, I snap also, and this is you. If someone sees the picture, you say, okay, maybe this is gift. They say, gift was standing second in the row. This other one, gift was standing third in the row, right? So this is different from this. So since the arrangement matters, we call this what? Permutation. Good. So knowing that this is permutation, we'll be using the formula for permutation. And the formula for permutation is what? N factorial all over what? N minus r all factorial. Is it not? Good. Now, n factorial there, n is what? N is what? 5, right? So 5 factorial all over 5 minus what? 5 minus what?
5 minus 5.
5 minus 5 factorial. Now look at this. We have 5 persons. We want to arrange the 5 of them. We want to be switching the position of 5 of them. We are not saying, okay, switch 2 persons, switch 3 persons. We are switching the position of 5 of them. So our arrow here is still 5. So in this case, 5 factorial all over 5 minus 5 is what? 0, right? So 0 factorial. Now, remember, this is not 5 divided by 0. If not, it will be undefined. But this is 0 factorial. So, this is the same thing as 5 factorial. This is like nothing. It's like nothing. So, what we have here is 5 factorial. 5 factorial is the same thing as 5 times what? 4 times 3 times 2 times 1, which is what? 120 ways. So there are 120 ways you can arrange 5 persons in a picture. 120 ways. So you can still see that once you know if it is combination or permutation, you can go and find your way around it. Let's look at this. Permutation of distinct objects. If we are talking about distinct objects, how do we go about it? Now in example 1, in how many ways can 3 yellow, 4 red, and 5 blue balls be arranged in a string of Xmas 3 lights with 12 sockets? You have 12 places to put the balls, and you have 3 yellow balls, 4 red balls, and 5 blue balls. If you want to solve this, this is the formula you use. N factorial all over N1 factorial times N2 factorial, N3 factorial, like that. Now, this N1, N2, N3 are the number of distinct objects we have. So in this case here, from the equation, we have a total number of 12 sockets. So you use your 12 factorial all over. The first distinct object we have there is what? Yellow, right? So we have 3 factorial, 3 for yellow. Next is what? 4 factorial. Next is what? 5 factorial. This all. So you can solve. 12 factorial is the same thing as what? 12 times what? 11 times 10 times 9 times 8 times what? 7 times 6 times 5 factorial. Since we have 5 factorial down, let's cancel that one out. 3 factorial times 4 factorial times 5 factorial. 5 can cancel 5, right? Is it not? So we'll be having, you calculate this out, 12 times 11 times 10 times 9 times 8 times 7 times 6 all over 3 factorial times 4 factorial. So everything up will give me what? 12 times 11 times 10 times 9 times 8 times 7 times 6. Give me what? Okay, let's do this together. Let's do this together. Let's cancel out. 3 factorial is the same thing as what? 3 times what? 3 times 2, right? Let's leave times 1. Times 4 factorial is what? 3 times 2, right? Good. So at this point, you can 3 times this is 6, right? So this 6 can cancel this 6 out, is it not? 4 times 3 is what? 12. So this 12 can cancel this 12 out, is it not? Now you can calculate this now. 11 times 10 times 9 times 8 times 7 is what? With your calculator, you can just press out the answer, but in case you are not with access to calculator, find a way to cancel and cancel out. So this 111, this 110, is it? 110 times 9, 990, right? 990 times 8 is what? Times 7. 5 what? 440. All over what? All over 2 is what? 27 7 like this. That's all. That's all. Sometimes you see your options, they leave your options, the one that looks a little long. Sometimes they leave their options in factorial like this, so the work becomes easy. But anyway, just understand what you're supposed to do. Example 2, under that, how many ways can the letter of the word mathematician be arranged? First of all, how many letters do we have here in total? Now count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? Good. So we have 13 letters in total. But now you agree with me that some letters are repeated, right? So how many distinct letters do we have? Now we have how many M's? We have 2 M's, right? How many A's? 3 A's. How many T's? 2 T's. How many H? 1 H. How many E? How many I's? 2. Any other thing? How many N? How many C? 1. Good. Now these are the distinct letters. And remember, permutation of distinct objects. What do? You just take the total all over. So here we'll be having 13 factorial all over 2 factorial times what? 3 factorial times what? 2 factorial times what? 1 factorial times 1 factorial times 2 factorial times 1 factorial times 1 factorial. But you know, this is the same thing as 13 factorial all over 1 factorial is still 1, is it not? So let's just remove all the ones. So we'll be having 2 factorial times 3 factorial times 2 factorial times 2 factorial. That's all. You will now settle yourself out. Is it not? You settle yourself out. But most times it is good to arrange from small to big, like something like this. 13 factorial all over 2 factorial, 2 factorial, 2 factorial, 3 factorial. Still the same thing. I just brought the... So from here, you can multiply out. Now let's look at this together. More exercises. In how many ways can a disciplinary committee of 3 be formed from 10 members of staff of a college? Now, total we have 10 persons. You want to form 3 committee, right? 3 persons in the committee. And you want to select the 3 persons from the 10, out of the 10. So in this case, what do you think we use? Is it permutation or combination? Combination. Whether you take this person before this person or this person before this person, the fact is that they are the persons in the committee. So in this case, A, B, C is equal to B, C, A. Or anyhow you turn it. Do you get? So the order does not matter. What matters here is the people present, the person is present, not the order. So in this case, we use combination. And remember our combination formula. N factorial all over what? N minus arrow or factorial, arrow factorial, is it not? Now, our N here is what? How many persons do we have? 10, right? So 10 factorial all over 10 minus what? 3 or factorial, 3 factorial. Now we are having 10 factorial all over 10 minus 3 is what? So we have 7 factorial, 3 factorial. Is it not? So here you can say 10 factorial is same as 10 times 9 times what? 8 times 7 factorial, right? All over 7 factorial times 3 factorial. Is it not? 7 factorial can cancel 7 factorial out. So we'll be having 9 times 8 is what? 9 times 8 is what? 72. 72 times 10 is what? So 720 all over 3 factorial. 6, right? So this will give us what? 120. That's all. That's all. Any question? Now let's look at this exercise. In how many ways can the letters of the word totality be arranged? And options are given. Now first you count the letters. How many do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, right? So total we have 8. Total letters. We have 8. Now, how many distinct letters do we have? The distinct letters. T. How many T's do we have? We have 3 T's. How many O's do we have? How many A's do we have? How many L's? Another one there. How many Y's? How many I's? 1, right? So that's all. Now, if you look at this, permutation of distinct objects, we have 8 factorial all over what? 3 factorial, 1 factorial, 1 factorial, 1 factorial, but you know 1 factorial is still 1. So we are left with 8 factorial all over 3 factorial, which is 8 times 4 times, 8 times 7 times 6 times 5 times 3 factorial, right? All over 3 times 4 times 3 factorial, all over 3 factorial. 3 factorial cancels 3 factorial, and you're left with this. And this will give you what? 6720, which is option A. So this is the correct answer here. That's all. It will not even take you 1 minute to solve. Let's solve this together. Now, the next exercise is evaluate this. If n equal to 15. Now recall that when we're writing combination, we normally write it this way, right? And the formula we normally say was n factorial all over what? N minus what? Arrow factorial, arrow what? Factorial, is it not? Now we're given an equation like this: n plus 1, n minus 2. And we're given the value of n as what? 15, right? So let's just substitute. Yeah, if I add 15 here, 15 plus 1 will give me what? So this is just 15 plus 1, 15 minus 2. So this is 15 plus 1 is what? 16, right? 15 minus 2 is what? 13. So we can solve this out by saying, if we apply it into this formula now, we'll be having 16 factorial all over what? 16 minus what? 13 factorial, 13 factorial, is it not? So this is same thing as saying 16 factorial all over 16 minus 13 is what? 3 factorial, 13 factorial, right? Good. Now if that is the case, I will have something like 16 factorial is something as what? 16 times what? 15 times 14 times 13 factorial, right? All over 3 factorial times 13 factorial. But 13 factorial can cancel out 13 factorial, right? So we are left with this. This will give me what? Everything up will give me what? 16 times 15 times 14 will give me what? 3,360 all over 3 factorial is 3 times 2, right? Which is 6. Which will give me what? 560. So that's the answer to that question. That's the simple answer to that question.